Hello and welcome back to my CATIA V5 tutorial series. Today we're going to dive a little bit deeper into one of CATIA's core features, which is the sketch. As you might already know, there are two types of sketches, the regular one, which is also called sliding, and the position sketch, which gives you a little bit more control with regards to the origin and orientation of the vertical and horizontal axis of the sketch. So let's begin with the position sketch. The button looks like this. You click on it. First, it requires a reference plane as an input. You can select your plane. Default it's implicit, which means it's basically like a sliding sketch. But you can also change this point of origin. You can have the implicit one, the part origin, which is uses the part origin, the 0, 0, 0 point as an origin for the sketch. Projection point, this will project a point onto your reference plane and use that as the origin. So if I go projection point and I click this, see, it'll project this and use this as my axis system for the sketch. This is by far the one I use the most, and it's really interesting. The rest are kind of like a bonus, but not really that important for me. Intersection, two lines. You can choose two lines and it'll create an intersection between them, and it'll use that as the origin. Curve intersection. We'll talk about this a little bit later. First, let's talk about the middle point, which is kind of similar to the intersection between two lines, but it only uses one line, and it will just pick the middle point and project that onto your plane. You see, this point is actually on my reference plane. Right? The weird one is the very center. This one will actually require a surface as an input, and it will kind of like automatically calculate the geometrical center of that surface and project that onto your reference plane as before. Okay, we did not talk about the curve intersection one. This one is a bit more different, not much, but it is slightly more interesting. So for the curve intersection, you select your reference plane and you select the origin of the curve that intersects your plane, your reference plane. So if we pick this line, it'll put the origin here where the curve intersected. Good. Now we have our reference plane, we have our origin. All that's left for us is to pick our orientation. So for orientation, we pick our reference plane, we pick our origin, we leave this one as implicit. Orientation, you can have either parallel to X, parallel to Y, parallel to Z, or you can pick your components, where it gives you the three directions and you can choose values for each one. So if I put 1 here, it'll be parallel to X, and the rest are 0. If I put 0 here, 1 here, it'll be parallel to Y. If I put 1, 1, it will pick a direction 45 degrees between X and Y, like this. So that's the components. Now, the most common one that I use is parallel to line. This is really important. Parallel to line, and you have to pick a line. Let's say this one, it'll create the orientation parallel to this one. Let's see, we wanted this one, it'll create it parallel to this line. There is the option to have it through a point. This will basically create a line between your origin and another point that you select. So let's say we select this one, it will choose this orientation for your sketch. Intersection plane is basically, it will take your reference plane and intersect it with another plane, and that intersection between two planes is a line, and that is your direction. The normal to surface one is the one that's a bit interesting. You can pick a surface, let's say this one, surface or plane, doesn't matter, and it will basically create a normal direction between this point and your surface, and use that as a direction. And obviously it will project that onto your reference plane here. Okay, you can obviously choose which direction you want it to be. You want it to be to match this this reference. It's either the V or the H, vertical or horizontal. The other one is 90 degrees to that, and you can choose to reverse H or reverse V, and you can swap them together. And that's it for how you define your sketch. Now you're maybe asking why would you need to have a position sketch rather than a regular sketch? Well, it's very easy to work with it, and it's slightly more stable. So let's say we have this this plane as the reference. The origin, we pick part origin, or maybe better yet, projection point, this one. And the orientation is parallel to line. Like I said, this is the most common one. And we have our sketch. And we want to put, I don't know, something like this onto our sketch, and something like this. This is our sketch. Now, let's say in the future we want to move this somewhere else. Let's say to this location here. Well, that's very easy to do. You find your sketch element, right click on it, and you have change sketch support. You reselect this this origin, the reference plane, you reselect the origin, and the parallel to line, you select this one. And then you click OK, and it just moves here. And everything, every dimension that you may have put into this will basically work the same. But there's a trick to this. You have to use the sketch origin as a base for your constraints. Now that we know all about creating the sketches, we have to figure out what we actually put in them. So first things first, I would like to start with a simple tip, and it's mainly about when using constraints in a sketch. I've always said this, but try to use the reference plane as the reference axis as a base for your constraints. So if you have something like this, you don't want to have constraints like this and like this related to other geometry. You most likely want to have it towards the axis system, so that when you try to actually modify something, it doesn't jump around like this and mess up all your sketches. What you actually want to do is to have it more like this. As much as you can, constrain to the axis system. So then when you actually modify something, you only modify that element. See? Sometimes may be unavoidable, but see how this changes only the stuff you wanted to, and not your entire sketch. This is a much better practice than doing it the other way. Okay, second, let's talk a little bit about trimming in sketches. As you know, you have the QuickTrim button, where you can just trim like this. click on the thing you want to trim and it'll trim it. There is also the trim, which you select also the direction you want to trim. So you select one line, then the other one, and it trims it like this. If you say wanted to keep the other ones, you have to click on the line that you want to keep, click on the line segment that you want to keep. Right? The trim is also doubles as an extend command. So if you have two lines like this, you can extend them like that. That's very good to know. There is also a command called break, where it basically trims this line with this one, but it doesn't delete it. It just creates a different segment here. If you were to trim a circle, this is where the trim command comes in handy, because QuickTrim will just delete the segment like this, and I guess you don't you can choose which one by clicking on it, but I think trimming circles is much more appropriate to use the proper trim command. Okay, now one other thing I would like to show you. It's when creating geometry, there is a specific command that is called line normal to curve. I won't go through the rest of them because I assume you already know how to create circles, squares, and stuff like that. This is really simple stuff, but this one is a bit more unique and a little bit more complicated. You can create a line normal to a curve in a point. So you have this curve, and then you put this point, you pick this point, and it will create a line perpendicular to this curve. See, now if you choose to move this point, this line will always be constrained like that. That's really useful to know. And it's a very, very useful command, which is specific to the sketches. All right, now let's just get rid of this. I'd like to show you some other useful stuff that you can do in the sketch. It's mostly related to the mirror and symmetries. So if you have some geometry here, you can symmetrize it to the other side directly by using the mirror and picking like the mirroring plane. And it'll just create this geometry mirrored and with automatically put a symmetry constraint. So when you move this, the other one moves as well. That's very useful to know. It could come in handy sometimes. These ones are pretty obvious what they do. It's the scale and offset. It's I will not go through them in such details. Scale, you just scale it up and down. Offset creates an offset of the curve. Automatically puts a constraint on it. That's really simple stuff. Okay, now what about using the output of these sketches? Normally what you want to do is have like one closed contour for each sketch, but sometimes you want to create something. It's much easier to create it like in a master sketch and do something else do something else afterwards. So for that there is a very useful neat trick which is called output feature and output profile. So what you do, you basically select one of these features that you drew, let's say this one, and create an output feature from it. It'll create it here. Let's say you want an output feature from this, an output feature from this, and for this, because it's created from multiple features, you want to have an output profile. You can just select it and it'll automatically propagate through the wireframe. And now you have like 3 new features as outputs from the sketch, then you can individually use. So let's say we wanted to have like a revolve around this. Where's the revolve? I can can never find it. Here it is. Revolve this profile around this axis. Oops, something like that. And then for the other one, we just want a simple extrude. Let's say X direction. I think I picked a vertex, right? Right. So you can use them individually without any issues. That's a very useful trick, and you can keep things organized with them. Okay. Next tip, we will be working on constraints. This is very useful to know. Let's say you have a square with multiple rounded edges, and you want this radius to be 5 millimeters. What you can do is obviously select each one of them as 5 millimeters. Normally that's what you do, but then let's say you decide to switch it to 6, and then you have to do it all over again. That, well, I'm telling you, you don't have to do that. You can actually link them together. You double click the constraint. Here where it says the radius, you right click, edit formula, and then you can go and click on the link on the value that you want, and click OK. Okay, you did this once for all of them. Edit formula. You make sure you link it to the same one. It's probably best to do it like that. Edit formula, this. So now when you change this one, all of them change together. Isn't that cool? Now, it doesn't have to be the exact same value. You can actually put formulas there. So if you have, let's say, this one, which is 60 millimeters, and you want this line to be half of that, you can put a constraint on it, edit the formula, select this, and divide it by 2, let's say. And now it's 30 millimeters. You can divide it by 2 and add 5 millimeters. Make sure you put millimeters afterwards, because it'll consider this as 5,000 millimeters if you put 5 without a unit. Now it's 35. Now the only thing you can't do is put a formula for the diameter. Why? I have absolutely no idea. But you can just switch it to the radius and edit the formula here. And you can double it if you want the diameter. Okay, now let's talk a little bit about projecting stuff onto the sketch. I told you that it's always good to project stuff on your sketch rather than creating a geometry and linking it directly to the 3D. It's always a little bit more stable doing projecting it. So you can project 3D elements. You can select which elements you want to project from a 3D. You can choose this one, and it'll just project it onto your sketch. See? That's very easy to do. The other very useful thing you can do is actually intersect 3D elements. That's probably the one you're going to end up using most, is intersecting it. So you can just click the body and it'll create an intersection. And then here you can start modifying stuff and using this as however you want. Okay, now that we know how to project stuff, let's talk a little bit about visualizations. So in the sketch, you can choose to view it like this with the 3D on, but you can also choose to hide it. So you have here in your visualization, this is the usual view, and you have the low light view, which makes everything darker so you can better view the sketch. And you can also choose not to view it with no 3D background. That's really useful if you have a cluttered screen. Also here, this will this will influence how you interact with your environment while in the sketch. So this is the normal one, pickable and visible background. Unpickable background, that means you will not be able to select anything else by mistake. So if you put a constraint like this, it will not allow you to select the part. That's just so you don't make a mistake. You can have low intensity background. It's like a low light, but a little bit different. And you have unpickable low intensity background, and now you cannot select it. All right, so that's about it for the sketches. And as you can see, my CATIA is starting to act up a little bit because it doesn't really like to use all those features. Oh, that's CATIA for you. Yeah. So my CATIA just crashed now because I was playing a lot of the visualization stuff. That's known to happen from time to time. So without making this video any longer, thank you for watching it, and please subscribe if you haven't already.